Okay, AB Calculus AB, Unit 8, Day 1, assignment, office hours. So all these answers in the back of the book, hopefully you checked them. I'm going to go ahead and do them now. So this says evaluate the integral and check your answer by differentiating. So they're saying, and this is true, these are easy to check your answers because you guys should be really good at taking derivatives. If you take the derivative of your answer, you should get what we started with. Now the strategy here, I would use something like I showed you guys in class. I would actually distribute this first and get x plus x to the fourth. You really need parentheses around these, and you need to write the dx every time. Now we want to go backwards. So this is x to the first, so it's power rule backwards. You add 1, divide by the new exponent, right? Bump it up 1, divide by the new exponent. Plus c has to be on every answer. That's it. That's 13. Okay, 15. It's the integral of x to the 1/3, 2 minus x squared dx. Now I'm going to use the same strategy, but you guys should know that you can't just distribute exponents. You have to FOIL it out. Now I think I could probably do that in my head without writing it like this, but this might be helpful for some of you guys. So I would FOIL this all out first. So this is going to be 4 minus 2x minus 2x is minus 4x plus x squared. And then we're going to distribute this guy in after that. And we're going to get 4x to the 1/3 minus 4x to the 4/3 plus x to the, what's that going to be, 7/3. And so now when we integrate it, it's going to be 4 times x to the 1/4 divided by the new exponent or multiplied by the reciprocal. Right? I think I messed up right here. Bump it up 1. So that'd be 4/3. 4/3 divide by the new exponent or multiply by the reciprocal. Okay. Bump it up 1. That would be adding 3/3 to this. So it's 7/3 divide by the new exponent multiplied by the reciprocal. Plus x to the 10/3, add 1, which is the same as 3/3, divide by the new exponent multiplied by the reciprocal. Now we're going to clean up for the final answer. We're going to get 3x to the 4/3 minus 12 sevenths x to the 7/3 plus 3/10 x to the 10/3 plus c. Okay, so that's 15. 17 is going to be x to the 5th plus 2x squared minus 1 over x to the 4th dx. Now for this one, I guess I'll go ahead and zoom in here. I guess we could give you guys a closer look at my work. This one, I'm going to actually, in a similar way, distribute the division. So this is going to be x to the first power plus 2 over x squared minus 1 over x to the 4th. So I distribute the division. Now for integrating, it's going to be easier if I change these to negative exponents. So this is going to be 2x to the negative 2 minus x to the negative 4. This is going to be power rule. So we're going to bump it up 1, divide by the new exponent. Bump it up 1, divide by the new exponent. Bump it up 1, divide by the new exponent, plus c. Final answer, it's going to be x squared over 2 minus 2 over x. In the denominator, the 2 doesn't have the negative exponent. Plus 1 over 3x cubed, negative negatives becomes positive, plus c. So that's your final answer there. Okay, 19 is going to be 2 over x plus 3e to the x. Now, what some people are going to think to do here, which doesn't sound like a bad idea, change that to a negative exponent. Okay, now if you were to do that, then you'd be like, oh, this is a power rule, bump it up 1, divide by the new exponent. Division by 0? No. Nope. The antiderivative, this is a special case, of x to the negative 1, 1 over x, is natural log of the absolute value of x. Plus 3, the antiderivative e to the x is e to the x. Plus c, that's your answer. So you got to watch out for that one. Okay? But it's going to be obvious. If you divide by 0 in the middle of your work, that should bother you. Okay, 21 is 4 sine x plus 2 cosine x dx. Need those grouping symbols. So the antiderivative here, it's going to be 4. It's going to have a cosine x, but the derivative of cosine is a negative sign. So remember, you can check your answers. If you take the derivative of this, it should give you what you had to begin with, right? Plus 2 sine x. And you're like, is it positive? Is it negative? Well, if you take the derivative of sine, you get positive cosine. Perfect. If you take the derivative of cosine, you get negative sine. Not good. Add an extra negative. Okay? 23, the integral of secant x plus tangent x dx. Now, it might be helpful to distribute this, and you get secant squared x, and then you get secant x tangent x dx. Okay, that's better because secant squared, you should have memorized, is the derivative of tangent. So we're using derivative rules from last semester backwards. What gives you secant tan? That's one of the answers to derivative, right? That's the derivative of secant. Plus c. I always put the plus c. You're going to hate to lose points on your test because of a bunch of missing plus c's. 25 is the integral of secant theta over cosine theta d theta. Now, I don't really know how we're going to do this. Division, we haven't done a reverse quotient rule yet. So maybe we should consider rewriting these. Secant is 1 over cosine, right? And then we already have 1 over cosine, right? And so then that would give you 1 over cosine squared. What's another way of writing 1 over cosine squared? Secant squared, right? And secant squared is the derivative of tangent. So sometimes you're going to have to get a little creative and rewrite things. Try it if you don't see it right away. 27 is sine x over cosine squared x dx. So now this is a new idea. Let's see. Well, we could try and use some of our rule. I think on 27 they actually encouraged you to do this u thing, but I'll try that in a second. Let's first say, well, let's break this up. This is sine over cosine times 1 over cosine. So another way to think of this is tangent, and then 1 over cosine is secant. So this is secant tan, right? Which is the derivative of secant. Okay, let me show you a different way of doing this that we're going to use a lot, okay? And I think they encourage you to do this. Let's make u equal to cosine x, and then du would be the derivative of u would be negative sine x, and then you put a dx over here. And so you see the sine x dx here. Now, I don't want that negative, so I'm going to divide by negative over here. I'm going to replace sine x dx with negative du. And I'm going to replace cosine with u. So this is going to be negative, I'm going to put the negative out front, du over u squared. So I'm just changing the way this looks. Now, when I write it like this, I think, oh, well, that's just a power rule, right? And so I'm just going to bump it up 1 and divide by the new exponent plus c. But at the end, we're going to want to rewrite it back with the original stuff. This u is a temporary variable. So u is actually cosine and as a negative, so it's going to end up in the bottom. So it's going to be positive 1 over cosine x plus c, which would be okay as an answer, but which is also the same as secant x plus c. So we got the answer. But this is a method we're going to use a ton. It's called u substitution. We could get away without it on this problem, but it's something good to start looking at. 29 is the integral of 1 plus sine squared theta cosecant theta. So this one's kind of looking crazy. So we might consider rewriting it, just trying to clean it up, make it something else that looks more familiar. So cosecant is 1 over sine, right? And then we could totally simplify this, cancel one of the signs out with sine squared on top. So now we have 1 plus sine theta d theta. Now we can integrate each term on its own. The integral antiderivative of 1 is x. What would you take derivative of to get 1? 1x. Minus cosine theta. You need the minus because the derivative of cosine is negative sign. I don't want a negative, so I need an extra negative to cancel it out. Plus c. Okay? Oh, actually, this should be theta, by the way, not x, because everything in here is theta. So everything should be theta. Okay? 31 is the integral of 1 over 2 square root of 1 minus x squared minus 3 over 1 plus x squared. Now this one looks crazy. You might try some basic things first, but look, there's going to be a 1/2, but this is the derivative of inverse sine, right? Minus 3, any numbers, just go in front of your answer. 1 over 1 plus x squared, that's the derivative of inverse tangent. This is actually a fast one, but it requires you to recognize some of our special derivative rules that we don't use as much. 33 says evaluate the integral 1 over 1 plus sine x dx by multiplying the numerator and the denominator by an appropriate expression. So right now you're stuck. You're like, how do I integrate this? You can't break this up. But they give you a hint. Multiply the top and bottom by the same thing. Here's the trick. We're going to multiply the top and bottom by the conjugate. That's when you multiply a two-term expression by the same expression, but change the sign in between. It's called the conjugate. Now, if we do that, let's see what happens. The top is going to be 1 minus sine x, right? The bottom is the difference of squares. So you're going to get 1 minus sine x plus sine x minus sine x squared. The two middle terms drop out. So you can get 1 minus sine x squared. Now, right now, you're like, well, how does that help me? Well, now we're going to use a Pythagorean trig identity. You guys remember this, sine squared plus cosine squared equals 1, right? So 1 minus sine squared, if you subtract this to the other side, is another version of the Pythagorean identity that says we could replace that with cosine squared. Now you still might be thinking, well, what do I do? Well, at least now we can distribute the division on the bottom. When it was multiple terms, I couldn't break it up. So I'm going to go ahead and distribute it. 1 over cosine x squared minus sine x over cosine squared x, right? And then this first one, I'm going to rewrite as secant squared, which is a derivative rule I know. This one, I think I need to kind of break it up and rewrite it. 1 over cosine, sine over cosine. So these trig ones take a bit of practice and knowing your trig identities really well. So 1 over cosine is secant, right? Sine over cosine is tangent. And then you get secant tan. Well, that's a derivative rule I've memorized from last semester. So the antiderivative of secant squared is tangent. If you take derivative of tangent, you get secant squared. Antiderivative of secant tan is secant. And then, of course, we need a plus c. So that one was tricky. That one had a lot of tricky trig in it. But anyways, we're going to need to practice these a lot, just like we had practiced derivative rules a lot to get really good at them. But you really, I think you just got to put the time in on these and do lots of them and, catch your little mistakes. So